Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on LNG network modeling in GAP software. All right, and in this video we are going to talk about, connecting this GAP file with MBAL and Prosper file, and also defining the pipelines as well as the separator. All right, so again, I'm not going to build or to draw the network from zero because it's going to be time consuming. Okay, we have learned about that in previous exercise with oil network modeling. So now I already have everything drawn, and we just need to review the size of the pipelines and connect this GAP file with MBAL software as well as the Prosper, and maybe later PVTP. Okay, so everything you already know except maybe LNG plant. Okay, so to to get this LNG plant, we need to select the separator actually. Where are you? The separator. This is reservoir, of course, this one. Let's say I just try to put it there. Okay, now you see in select type, we have LNG process plant. Click on that and click on OK. There you go. You have LNG there. Okay, click on OK. That's it. Okay, so we take it from the separator. All right, now I'm going to delete it, of course. Okay, so by the way, there, LNG process plant, and if you enter this one, okay, the separator type or separation type, you need to ensure this to be, the LNG process plant. Okay, and then what else? I think it's already good. Okay, let's delete this one. Okay, now let's define the reservoir. I already have the, the MBAL software for the reservoir. So as usual, double click, and then you need to browse the file, and then that's it. You connect this GAP file with the already prepared MBAL file. Okay, so I already connected, by the way, with the MBAL software, reservoir_start. That's the name of the file, and it's valid. Okay, and maybe we can check the input. Brought data, no. Compressibility, no. Constraint, still blank. All right. And then what about setting up the MBAL as compositional? So let's go to summary. Here we have very interesting run MBAL. Okay, so we can run the MBAL software using this GAP software that's already connected with the MBAL software. Okay, and again, this is LNG process, so it's very important to consider or to use fully compositional rather than black oil. Okay, and by the way, we will modify the MBAL file, but we will modify by using this GAP software. Okay, to do this, we can open the MBAL file through this software to grab by accessing the tank system summary screen like this and selecting Run MBAL in the bottom right of the corner of this window. Okay, so we can click on this button, Run MBAL. All right. Very, very, very interesting. Now we are already inside the MBAL software. It's connected. Okay, so once the MBAL file is open, we can access the option, this one, from the main toolbar and open that. And then reservoir fluid, let's select general, and then tank model single tank, PVT model simple PVT, and production history by tank. But now compositional model, we go fully compositional. All right, and then enter the EOS model setup. Okay, and enter the same PVT information as we entered in the gap software. Okay, so Bang Robinson, and then this none, yes, full composition, of course, yes, correct CO2 density, yes, no lumping, 60 and 0, hydrofact, good, LBC model, and then component name only, molecular weight partial 45, and then for the path to surface and recycle, we select use separator train, and then use fixed composition. And just like what we insert in the gap, it's 200 at 80 degrees centigrade, no, 80 degrees Fahrenheit, and 0 PSIG at 60. Okay, and note that when linking a fully compositional MBAL model to gap, MBAL will automatically use the EOS setting defined in the gap, as it is the master control. Okay, so the MBAL will be the master, sorry, so the gap will be the master control of the MBAL file. Okay, so click on OK, good. And of course, we click on done, still red, because we need to set up something else. Okay, so now we need to enter the compositional PVT data. Okay, the next step here is to import the equation of state file into this MBAL software. Okay, and again, we are going to use the already prepared file. In this case, we are going to take fluid model, EOS model from PVTP. Okay, we will import the PVTP file into the MBAL, and we have that prepared already. Okay, so let's go to PVT fluid properties. All right, so we have oil still blank, gas still blank, gas injection, and water still blank. Okay, first we select the gas, and we need to edit composition. Click on this button. Very good. All right, it's a bit complicated, but don't worry, because we just need to import the PRP file. Okay, so click on this button. All right, so this is my PVT model file from PVTP, and the extension is PRP. All right, so click on this button and then click on open. All right, so the gap will automatically, or the MBAL will automatically load the EOS model that was built in PVTP, including the separator train that defines the path to stock tank condition. All right, so again, the MBAL will automatically load the EOS model that was built in PVTP in PRP file, including the separator train that defines the path to stock tank conditions. Yeah, the separator information. And we have, of course, the component names and the composition and all the properties here. All right, so everything is good. By the way, the viscosity model for oil and gas, we will use LBC model. So click on OK. By the way, do we have validate button here? Okay. No problem. I think we can click on OK. All right, so now the gas here becomes black. It's good, by the way. It's already good. And then we will not use gas injection, so leave it. And then the water salinity is 10,000 ppm. All right, and by the way, in this case, this is LNG case, so we will enter the gas composition. All right, and the gas composition that we enter, has vaporized oil. When the fluid goes below the dew point pressure, this program will automatically determine the equilibrium oil composition. Thus, we don't need to enter any oil composition. All right, again, the gas composition that we enter already contain the vaporized oil. Okay, so the oil itself, the condensate, has been characterized within the gas, the gas file or the gas fluid model that we have, that we prepare in PVTP and import it here. So when the fluid goes below the saturation pressure or the dew point pressure, the program will automatically determine the equilibrium oil composition. Thus, there is no requirement to enter any oil PVT data. Okay? All right, and then click on done. Almost there. So now we go to input and we go to tank data. Now we need to enter data here, oil lag, downhole ratio. We set it to be 0 because at initial condition, the reservoir is above the dew point pressure. So everything is still gas in initial condition. So the oil lag, the original oil lag will be 0. All right, and you can see here the name is reservoir, the temperature quite high, 255, initial pressure 5,320, and then porosity, cold water saturation, and then original gas in place 500 BSCF, and start of production January 1st, 2007. Okay, we don't have production history. Let's say it's a it's a new field, it's a virgin field, so we will not do history matching in this case. Okay, so we can click on validate and click on done. So the name becomes black. It means that it has been validated. Okay, so it's very good. And then from here, we can save. Okay, and maybe, yeah, you need to save it as, let's say, another file. Okay, like in previous case, it's an initial file. Now you can change it to final file. Okay, that's what I'm going to do. So you can click on file and save it. Okay, so from here we go back to the gap